Hey guys, Lissandro here, and once again another tutorial on electricity. This is the second tutorial in basic electrical engineering, and today what I'm gonna be focusing on is just basic electrical circuits. Okay. Try to bear with me on this, cause I really hate writing with this. I haven't gotten my tablet yet, which would be a lot difficult, a lot more simpler. I mean, because of the pen and everything. Okay, so basic, actually DC electrical circuit. Usually the we start off DC with DC because this is a lot simpler to explain and everything. And this is basically how Kare taught me in school and everything. Okay, so basic electrical DC circuit. Okay, now last time I gave you kind of a brief description of electricity, what it is, and everything. But today I'm gonna focus on some of the basic concepts in electrical engineering. So basically, last time I gave you kind of like an insight on an electrical circuit. I drew a battery, and basically I drew a battery. I hate this. It's kind of all half-assed, but I drew a battery, and okay, let's see here, and positive terminal. This is the positive terminal, and then the negative terminal, and I create a circuit here and everything, and I drew a basic light bulb and everything, just kind of filament here and everything. Basically drew this. So okay, so I have this I have this cir I have this circuit here, and as you all well know, whether you're considering the conventional current, which is basically what they call electron holes, which uh, travel from positive to negative, or you consider the electron current, which is basically the traveling of a electron from one point to to another, and basically current flowing through here and everything. And as if y'all remember correctly, I showed that the work done in this bulb, it, work done through this bulb, which is the basically the electrons flowing through the light bulb, will emit light and all. But what exactly is that? Well, what you call this is resistance. You call this electrical resistance and everything. Now, if now I'm gonna introduce you to something called Ohm's law. And basically, what Ohm's law uh, is states that voltage is equal to current times electrical resistance. Okay, or you can say current is equal to voltage. Hold on, I got messed up here and everything. Okay, voltage is equal to, I mean, current is equal to your voltage divided by your resistance. And you can keep on with this and everything. You can also say resistance is equal to. Let me finish here. Resistance is equal to your voltage divided by your current. Now, they'll also tell you that power is equal to V, which is your voltage times your current. Okay. Now, now you get to a point like what exactly is uh, what exactly is resistance? And basically, it boils down to the fact that there's power loss in your circuit due to heat. It is not only This is not only based on whatever load you put in here. Load is Your load is basically your resistance. Okay, we commonly call this your load. But the thing is, heat is not dissipating just from from your load. It's also dissipating from your wire because in reality, wire has uh, has electrical resistance as well, and not as much as your load, but it's always going to dissipate heat. That's why when you pretty much put on a huge electrical load, whether it's uh, whether it's DC or AC, whichever one you pick, and whichever one you pick, and mainly this happens with mainly with high power. Mainly happens with with high power because there's a lot of you're dealing with a lot of electrical potential that's going through here that uh, it pretty much makes the heat dissipation very substantial across the circuit. That's why you never use a thin wire on a high voltage or high power system, to be more precise, on a high power system because it's always gonna dissipate. You're always gonna dissipate a lot of heat, and the thinner your wire is, the more heat it dissipates. Um, that's why you have breakers in your cows and everything. When it gets to a point where that wire starts to overload and heat up, um, your breaker has your breaker box. Uh, Hold on. Pretty much give me a sec. Your breaker box has this magnet. Okay, there's like current flowing through here, and it goes through pretty much goes through a coil and a spring. I don't coil and a spring that's pretty much connected. And this is it's a piece of iron that's connected and all. I'm assuming it's a ferromagnet. I'm not really sure. I haven't opened one of those up and everything. But the thing is, as the as your current increases and everything, so does your heat. So when it gets to a certain point um, where it starts to overheat and everything, these are calibrated to a certain amount of current. And once it gets to a certain amount of current, the electromagnet is strong enough to break the circuit and get it to get it to cut, and that's when your power goes off and everything. It's for safety features because otherwise, if if it was directly connected without no breaker or anything, you your power line will start to heat up and everything, and it'll start to melt the insulator and catch things on fire. During the early stages when there was a lot of power lines and things of the sort, there was all sorts of different contraptions, all those sorts of different wires passing through the power lines and different contraptions. Back then, they didn't have these type of systems, and what ended up happening, there was a lot of electrical fires, you know. Okay, so they have this. They also have like thermal fuses. They not and basically what this is that it shorts out the circuit. There's two type of fuses. One, one of them one of them works through a via current, uh, via current, which is basically your current that flows through. And what happens is that your current heats up a wire that's thin that's eventually it melts out because the thin part can't tolerate a certain amount of current, so it blows out and it ends up cutting the circuit. The other one is worked to be a temperature, which is when it gets to a certain temperature, it shorts out. There's all sorts of different contraptions for and high power. I'm not gonna cover them all because they're endless and everything. But the basic idea is that what I'm trying to cover is that there's heat dissipation in your electrical circuit. There's always going to be some sort of heat dissipation. So because because of that, that's why they have all these security systems and all. But anyway, I guess this will be all for now and everything. And keep this in mind. These basic formulas: voltage equals current times resistance. Current equals voltage divided by resistance. Resistance equals voltage divided by current. And power is equal to voltage times current. So I'll catch you guys next time, and I'll see you later, guys. Bye.